Okay, another example of the law of sines. Now notice this one says two solutions. Okay, this is the type of problem that gives students heebie-jeebies here. So if you look at this, we can use the law of sines because we have an angle across from a known side. The problem is this is a small side, then a big side, then the angle. And in that case, there is two solutions to the problem. Now, how does that work? Well, see, here's the thing. If this side's 6 and this side's 8 and this side's 35, I could also draw an isosceles triangle on here like that. So this would be 6. And now I have another triangle where this side is 6, this side is 8, and that's 35 degrees. So there's two solutions to this thing. So what I need to do is I need to call this not beta, but beta 1. And beta 2 is that angle right there. This is gamma 1. And gamma 2 is that angle right there. Okay. So I'm going to use the law of sines just like before. So you can see I'm talking about the black triangle and then this triangle right here. I'm going to get solutions for both of those because they're both possible solutions to this. So here we go. I've got a side across from an angle, so I'm going to go with sine 35 divided by 6. And then I've got this 8 here, so that's going to go here, and I guess I'm going to have sine of gamma over here. So I'm going to go ahead and solve this. So here's my variable. Sine gamma is going to be 8 times the sine of 35 divided by 6. And that comes out to be sine of gamma is about 0.7648. And then I'm going to arc sine that. And gamma is going to come out to be 49.9 degrees. Just go one decimal place on the angles. Okay, now the question is that gamma 1 or is that gamma 2? Well, I can tell just looking at the picture. This is an acute angle. That's the acute angle right there. In fact, it's always going to give you the acute angle. So you're always going to find the bigger of the triangles first. So this is gamma 2. I can go ahead and put that in here everywhere. And I know this is 49.9 degrees right here. Now, once I have that, I can calculate beta 2. So beta 2 is going to equal 180 minus 35 minus 49.9 degrees. And that's going to come out to be was that 100? That's going to come out to be 95.1 degrees. Okay, so that's this angle up here. Okay, now I got to find B, and this is going to be B2. That's going to be this whole side right here. Okay, so I'm going to use the sine of 35 over 6. So sine 35 over 6. And I'm going to use the sine of 95.1 over B2. And so B2 is going to be 6 times the sine of 95.1 over the sine of 35. And that comes out to be 10.4. 10.42. So that's going to go right there. Okay, now we're going to work on the other solution. So that's the first triangle done. Okay, now, the calculator is never going to give you this obtuse angle here, but you don't need it to, because remember, this is an isosceles triangle, and the base angles of an isosceles triangle are equal, so this is going to be 49.9 right here. So I can take 180 minus 49.9, and that's going to be 130.1. And that's going to be this angle right here. That's beta 1, or gamma 1. Then I just do the same thing I did over here. So the sine of 35 over 6 is going to equal, whoops, nope, I can calculate beta 1 next. Beta 1 is going to be 180 minus 130.1, which is going to be 49.9 minus 35, so that's going to be 14.9 degrees. So this is going to be 14.9 right here. Okay, now I can use that to find B1 right here. So we're going to go back to the sine of 35 over 6 is going to equal the sine of 14.9 over B1. B1 is going to be 6 times the sine of 14.9 over the sine of 35. And that comes out to be 2.69. And so this side here ends up being 2.69. Now we've got two sets of answers. We've got two different triangles. And so we got that thing nailed down.